Hey guys, so the learning target for today is we will be able to convert degrees to radians and radians to degrees, okay? And I'm going to let you figure out your own essential question for today, but if I was to make one, I would probably ask myself something along the lines of, what is a radian, okay? Or what is the difference between a radian and a degree? All right, but I'm going to let you kind of figure out your own one for today, just kind of see how you do, all right? But let's dive right in. Okay, you can skip all this just silly stuff that's in here. Okay, so first off, I want to talk about an angle measure. All right, so this is an angle. You have a vertex. That's the point where two lines meet. And when two lines meet at a point, they create an angle. All right, and you have what's called an initial side and you have what's called a terminal side. Okay, and the angle is created by going from the initial side to the terminal side. All right, it's the how far it takes to get from here to here. Okay. Now that's just a general angle, but then we also have something called standard position. Standard position angles is where it looks like this, okay? Where we're on the x-axis and then we go counterclockwise around the x-axis, okay? And we call our ending side, we call that the terminal side, okay? Because it's our ending side, okay? So that means on the unit circle, we always read angles in standard position, okay? All right. So what is a radian and what do radians measure? Well, radians also measure angles, just like degrees do. Okay? The thing is, and I suggest here, you know what, I'm going to shut up and, well, I'll wait till this gets back around. Okay? But radians measure angles just like degrees do. Okay? And you can see this picture right here helps us understand how much a radian is. All right? This GIF that I'm waiting for it to roll back around to the very beginning is very, very helpful. Okay, so it's about to start, so I'm going to shut up so we can watch it. Okay, so we have a distance. We go around the circle. R, that's our radius. That's the length from the origin to the circle. We make it go up vertically, then we bend it to the circle. This measurement right here is 1 radian. So we took the hypotenuse, we went here, then we made it go straight up, and we bent it to the circle. 1 radian, 2 radian, 3 radian, then we go a little bit more, and that's pi, because pi is 3.14 radians. And then if we know half the circle is pi radian, then the whole circle must be 2 pi radians. Okay? So if a whole circle is 360 degrees, then a whole circle we can also say is 2 pi radians. Or we can say that if half a circle is 180 degrees, then half a circle is pi radians. Guys, this GIF is extremely helpful in explaining it, okay? But basically, you take the radius, you make it vertical, and you stretch it back to the circle, and that is what we call 1 radian. That's the angle measurement from here to here, okay? And then if you were to increase the angle measurement going around the circle, we would eventually end up with a total circle of 2 pi radians. Okay, so how do we use that? Well, for today, we have one single focus. We want to be able to convert between the two. Okay, so to convert degrees to radians, okay, so this is what we have. We have degrees, and we want radians. We multiply the degrees by pi radians over 180. Okay, to convert from radians, this is what we have, to degrees, this is what we want. We multiply radians by 180 over pi radians. I'm sorry, we multiply radians by 180 degrees over pi radians. Okay? So let's dive into some example problems. 135 degrees. All right, I have 135 degrees. So I have 135 degrees, so I need to multiply degrees by pi radian over 180. So I need to multiply this by pi radian over 180 degrees. So what allows me to happen here is the degrees cancel because I have a degree on top and a degree on bottom. So then I get 135 pi radians all divided by 180. Now I just simply need to reduce. 135 over 180, I honestly don't know what that reduces to off the top of my head, so I'm going to cheat here. If my calculator turns on, this is the longest part of every video I have. 135 divided by 180. I do want to leave it as a fraction, so I'm going to hit math, enter, enter, and I get 3/4. So you get 3 pi radians over 4. And there you go. So 135 degrees is 3 pi radians all divided by 4. So how many radians is 540 degrees? Once again, you have degrees, you want radians, so multiply your degrees by pi radians over 180 degrees. So we're going to multiply this by pi radians over 180 degrees. Well, I have degree on top, degree on bottom, so they're allowed to cancel, so that way I don't have 2 units. The reason I'm making sure I cancel out degrees is because otherwise I'd have degrees and radians, and I can't have that. Okay, I only need one kind of unit. Okay, so then I end up with 540 over 180, and I'm pretty sure that's 3. Well, I know the 18s and the zeros cancel, and then 54 divided by 18, yeah, that is 3. So I end up with 3 pi radians. So then I can say that 540 degrees is equal to 3 pi radians. What about negative 270 degrees? Well, I have degrees, I want radians, so I multiply the degrees by pi radians over 180 degrees. So pi radians over 180 degrees. Okay, so the degrees cancel, and then I can cancel out the zeros. Because guys, you can say this is over 1, you multiply top to top, bottom to bottom, and then you're reducing. Okay, 27 and 18, they both share 9 in common, so that's going to give me 2, that's going to give me 3. So I'm going to end up with negative 3 pi radians all divided by 2. Okay, let's go the other way now. To go the other way, we multiply radians by 180 degrees over pi radians. Okay, I have a radian on top, radian on bottom. I have a pi on top, a pi on bottom. So this is now a 1 right here, so I can say 1 times 180. Don't forget my negative sign, so I get negative 180 degrees divided by, well, what's the only thing left at the bottom? 2. Negative 180 degrees divided by 2, well, that's just negative 90 degrees. There I go. Alright, let's try this next one. 9 pi over 2 radians. To get to degrees, I multiply the radians by 180 degrees divided by pi radians. Okay, so the pi's cancel, the radians cancel. 2 and 180 cancel, and 180 just becomes 90. So now I just get 9 times 90 degrees, which is 810 degrees. And there we go. Last but not least, guys, is converting 2 radians. Okay, 2 radians, to multiply radians to degrees, multiply radians by 180 degrees divided by pi radians. So I multiply by pi radians. Sorry, I divide by pi radians. Radians cancel. There's no pi here, so the pi is not going to cancel this time like it has been in the other 2 problems. But 2 times 180 is 360, so I get 360 degrees divided by pi. That's as far as I can go for this problem, if I don't want a decimal approximation. Alright. Okay, guys, I know that video is short and sweet. The trick is just to remember what to multiply by what and to cancel out correctly. Alright, guys, thanks for watching. Let me know what questions you have.